Welcome back to a new machine learning tutorial. In this video, we are going to talk about elastic net regression. We are going to talk about the theory behind the algorithm. We are going to code it using Python. And we are going to do hyperparameter tuning for optimizing the model's performance. Let's start coding. I will be using Visual Studio Code as the code editor. You can use any code editor that you want. I'm going to close welcome page. I'm going to create something like elastic net regression.ipmb. And next I'm going to select my kernel from here, 3.11.4. Then I will say elastic net regression, and now we can talk about the topic. So this is a type of linear regression model that combines both lasso, which we can also refer as L1 regularization, and ridge, which we can also refer as L2 regularization penalties, to prevent overfitting and handle multicollinearity. So we are going to be combining lasso and ridge, which we can also refer as L1 and L2 regularization. The model balances the effects of L1 and L2 penalties to create a more robust model by allowing both feature selection and shrinkage. Also, I have tutorials about these topics. You can check my machine learning tutorials playlist if you don't know about lasso or ridge and want to learn about them, but if you don't know, it's not a problem for this tutorial. And let's write the linear regression formula and talk about it deeper. So y is going to be equal to beta 0, our intercept, and we are going to have beta 1 x1, beta 2 x2, 2 beta n xn. So this is our linear regression formula, and in here L1 penalty, which is lasso, encourages some coefficients to become exactly 0, promoting feature selection. So we are going to make this some coefficients nearly 0. And L2 penalty here, which is ridge, shrinks coefficients smoothly, especially when features are highly correlated, stabilizing the model. So we are going to be using that when x1, for example, with x2 really correlated, and we want to get rid of this situation, which we refer as multicollinearity. So we can directly start the coding right now. This is enough for the concept explanation. What I'm going to do is I will say from scikit-learn.datasets import make regression for data creation, and also I'm going to import numpy. Next up, what I'm going to do is I will say x and y, and I'm going to say make regression. Number of samples is going to be 1000, and number of features, let's say 20, and I'm going to add a noise like 10. So I'm going to show you the x matrix with 20 features to you, and y vector we have a regression problem in here, as you can see. So I'm going to be deleting this matrix from here and this vector. So next up, we are going to build the base model firstly, then we are going to do parameter tuning for testing if we can find better performing model by hyperparameter tuning. And I'm going to be explaining the parameters we are going to tune. So let's start. I will say from scikit-learn.linear model import elastic net, and next up I will say from scikit-learn.model selection import train test split, and for the model evaluation I will say from scikit-learn.metrics import mean squared error. So we have our imports right now. The next step is going to be the train test split. So we will say x train, x test, y train, and y test. We are going to say train test split. We will pass x and y, the things that we created in here. And I'm going to set the test size as 0.2, which means that 20% of the data is going to be in the testing set and 80% is going to be in the training set. And I'm going to explain this concept a little bit, but if you want to learn it detailedly, you can check my machine learning tutorials playlist. I have a tutorial about it, and I'm going to be adding that playlist link in the cards of this video and in the description of this video. So we are going to have two sets, training and testing set, and we are going to train our models with the training set we have, and we are going to make predictions with the model we trained using x test, and we are going to compare the predictions with the y test values we have. So we are going to be evaluating the performance with the y test and x test, and we are going to be training the model with the x train and y train. So let's initialize the base model. Elastic net is going to be equal to the elastic net. Next up, we are going to train our model by fit method with training data we have, like this. and we have this value 0.0. It runs instantly. Next up, we are going to make predictions with xtest using predict method and passing xtest. So we have an array like this. Let's save it to something like y predictions. And next up, what we can do is we can say mean squared error. And I will say y test with y predictions, and here is our mean squared error. So in this metric, we want value to be lower if we want a better model. So let's see if we can do that with hyperparameter tuning, which means optimizing the model's parameters for better predictions. So we are going to have two main parameters in here. One is going to be the alpha, which is the overall regularization strength. It controls the degree of both L1 and L2 penalties. And we are going to have L1 ratio, and this controls the balance between lasso and reach. A value of 0 means reach penalty only, and a value of 1 means lasso penalty only. Values between 0 and 1 balance both. And we are going to use cross-validation to tune alpha and L1 ratio hyperparameters using elastic net cross-validation, which automatically tunes these hyperparameters by searching over a grid of values. So I will say from Scikit-learn linear model import elastic net cross-validation, and next up we are going to set it using elastic net cross-validation like this, and I will say elastic net cross-validation L1 ratio. Let's give values in here, like we are going to pass a list inside here. We can give 0.1, 0.5, 0.7, 0.9, and I think it's enough. And next up we have alphas in here, and we can give 0.1, 0.5, 1, 5. Actually, let's give floats 1, 5, and we can give 10 like this. And I'm going to set cross-validation as 5 for having 5 folds. And next up, I'm going to train it using elastic net cross-validation.fit xtrain and ytrain. And when this finishes, I'm going to be re-recording. It finished instantly, so there's no need for cutting the record. And let's see the best parameters selected. So for that, I will say elastic net cross-validation alpha like this, and the selected alpha is 0.1, and let's continue with the L1 ratio. It's 0.9. Okay, so let's see our mean squared error value by making predictions with this new model. Elastic net cross-validation.predict xtest, and we have our prediction array in here right now. Now what I'm going to do is I'm going to call mean squared error, and I'm going to pass y test with y prediction cross-validation, and our mean squared error is dropped to 107, and it was 4000. So we improved our model using hyperparameter tuning. Great. So let's summarize what we did in this video, and then we can finish this coding tutorial. So we started by talking about the elastic net, and we write the linear regression formula in here and talked about the lasso and reach separately. Next up, we create the dataset. I showed you the x and y. Next, we make our imports. We imported elastic net train test split mean squared error. We applied train test split with the test size of 0.2. I talked about the concept a little bit. Again, you can check the playlist in the description for more information on machine learning topics. I have like more than 50 videos, and in here we initialize the base model. Next up, we train the base model and we make a prediction, and our mean squared error is 4000 in here. Then we talked about the parameters we can pass, and we imported elastic net cross-validation. We gave range for L1 ratio and alphas. Next up, we used fit method on the cross-validation. Let me come to there. And we trained our model like this, trying out these values and finding the best one. Next up, we checked the best alpha value and best L1 ratio value, and we make predictions with the cross-validation model, and our mean squared error is dropped to 107, which means that we improved the model. Let's get to the outro. Thanks for watching this tutorial on ElasticNet. I have a machine learning tutorials playlist where I have more than 40 videos just like this one. You can reach that playlist from the cards of this video or from the link in the description. Also, I'm sharing a new data science video every week on my channel. You can subscribe to my channel for more videos like this. Have a great day.